Hi everyone, really happy to be here today to talk to you about some issues at the intersection of NLP, AI ethics, and now game theory. So my work has been primarily on modeling annotator disagreement for language tasks, and today I'd like to talk to you about why it's so interesting to be thinking about this now, not just because these LLMs are finally really starting to work very well, but also because people who are not researchers are starting to use them. Both my grandma and my 5-year-old cousin know what I do now, which feels weird, but nice. But the other issue that we see is that although these models are being used for many very useful applications, we're also seeing a lot of harms. And today I'd like to argue that many of these harms stem from the assumptions we make about the interaction between models and the people who are using them. We have this idea of how a model interacts with the user. But there is no the user. There are, in fact, many users. They're all people who are coming from different backgrounds, different communities. We might also think of this as different agents with different utilities. They care about different things. They use these models for different purposes. And because of the different ways in which they're interacting with these models, we see these models make undue assumptions and misinterpretations, which result in outputs that can be, to various extents, disparaging or stereotyping or unhelpful, and ultimately result in reinforced discrimination. And so today I'd like to talk about 3 issues that come up here. What can go wrong in these settings, what we can do about it by really trying to understand individual people's preferences, and finally, what comes next at this intersection. So let's start by looking at how we might train a model. So we're training a model for a machine learning task, maybe something relatively clear-cut, like find the subject of this sentence. So we need to collect some data. We need labels for that data so that we can train our model. And so we can ask someone to label this data, but we know from experience that people might get the answer wrong. They click the wrong button. They don't understand the task. Maybe you're using something like Mechanical Turk where there's lots of spam. So instead of doing this, we might ask several people. Probably not this many, but certainly more than one. And so we can aggregate their responses and see that, okay, the majority thinks that Alice is the subject of the sentence, and we can use that data to train our model. Now, suppose we're looking at a task that's not quite so simple, like looking for hate speech or offensive text. Again, we can ask multiple people for their opinions on this example and aggregate their labels to get the label that we'll use to train our model. But when we start to look at who is providing these labels, we start to see issues that come up in this setting. So here we have an example where this statement is targeting women, and the women in this particular sample of annotators are a minority of that data. And so their label gets essentially completely overridden by the majority vote. So we will not learn that all the women who annotated this example disagreed with this label because of this issue with aggregation. And so the trouble with aggregate annotations is that by design, they obscure the opinions of groups with lower representation among the annotators. Now, in many settings, it's quite useful to assume that all disagreement is noise. But when we have tasks that are less clear-cut, what we end up seeing is that for these tasks, disagreement can stem from things like differing interpretations. So what does toxic or hate speech mean to different people? Different values that users have, what they care about seeing on the internet, and what matters to them, what's going to affect them in terms of utility functions. Their different backgrounds, and in many cases, the lack of a ground truth. There may not be one true label for what hate speech is. We are depending on what different people think in different settings. And the interesting thing here is that although this intersection of game theory and large language models is really just starting to grow, the intersection of game theory and language has quite a long history. Under models like the rational speak-back theory, we see that participants reason about the mental states of participants in a conversation based on prior information about their interlocutors and about the world. And what we see in a lot of these cases is that annotators, when they're given text, they're making inferences about the context and meaning of that text without knowing who said it. And they're making those inferences based on their prior understanding of the world, which tends to differ widely based on different factors like the annotator's demographics, the languages they speak, their views in terms of like political and personal views, their expertise on different topics, and what they think the task is being used for. The difference between, oh, let's figure out if this might be slightly borderline or whether I should ban someone from Twitter. And so all of these assumptions are going to change how they do their annotations. So to give you an example of how this might turn up in our AI models, what happens when we label this information? I'll go back for 1 second just to point out one thing. So down here, we've in prior work by some researchers at the University of Washington, they found that annotators disproportionately labeled African American English as hate speech. And although this might be attributed to poor data quality or models oversimplifying issues, what they ended up seeing was that white annotators would assume that text that had been written by an African American person had been written by a white person. So suddenly terms that might be okay to say within an in-group conversation were really inappropriate because they were being assumed to be, that they were being said by a white person. So these assumptions about the context turn up in how we annotate our models. So to see what that looks like downstream, I conducted a study looking at the quality of experience that different groups have when interacting with ChatGPT, looking specifically at speakers of African American English. And so this case study was looking specifically at politeness, and two specific aspects that I'll highlight here. One has to do with assertiveness. So we see that these models have issues where they'll provide false information, and they don't have a good way of providing uncertainty. They'll say something that's wrong, but they don't provide, they don't say, well, maybe, or I think, the way that a person might when we're saying something that we're not sure about. And so this undue certainty can cause problems. We also see that if you've ever used ChatGPT, it likes to say things like, I'm sorry, but as a large language model, I cannot, and so forth. So this is a very common phrasing that it uses, but not all apologies are created equal. If I spill a glass of water on someone and I say, oh, I'm so sorry, that's my fault, that's a very different apology for saying, sorry if I hurt you because you were standing in my way, right? Very different kinds of apologies. So we have apologies that are called like self-deficiency apologies, so my fault. And we have apologies that use excuses that distribute blame between the person you're apologizing to and the person apologizing. And what we see is that in response to African American English, these models are much more likely to use the type of apologies where that blame is distributed, so like I didn't understand you, that kind of language, as opposed to ones that have to do with self-deficiently. It's like, I can't do that, I don't know, that sort of thing. We also see that in terms of assertiveness, approximators, which are words that indicate uncertainty, like about or a few or things like that, are less common in response to African American English, which may make those responses come off as more assertive. So here we see that these issues where different types of language are interpreted in different ways filter through to the downstream behavior of these models, oftentimes in ways that are pretty subtle. And so in terms of the subtlety, we'll see things like, I don't quite understand, I'm not capable of, I don't understand in response to African American English, where they're talking about what you were trying to say, whereas in response to standard American English, we think things like, I am not capable. So that's the sort of behavior we're seeing. But in terms of this like general behavior where these harms can be quite subtle, one of the issues we're seeing is that as these models get more powerful, rather than seeing harms where, okay, someone says something and the model immediately responds with something blatantly offensive, luckily we have mostly solved this problem. Unfortunately, we've kind of pushed the issues into a space of generations that are really tricky to capture and can even be more pernicious because they're more convincing. So we see things like misinformation that's worsened by false credibility and confidence based on the language that the model's using. So it's no wonder when these harms are really subtle that we see that people disagree on what harms are. So on some work with some folks at Microsoft, we collected a large data set of AI-generated hate speech. And among the issues we found issues where models would produce things that seemed fine, but only if you ignore the context in which they were said. We saw issues where models would change or avoid sensitive topics in ways that might actually perpetuate harm. And we also saw a very strange issue where models would impersonate a member of a group facing discrimination and then perpetuate a stereotype about that group. So it would be like, as a woman, I think, and then say some stereotype about women. All of these are presumably behaviors we want to avoid. And all of these are behaviors that are quite difficult to capture. So if we're looking at issues like this, the question is, how does the understanding of how different people interpret language help us deal with this sort of problem? So we have this issue here where we have some people who might perhaps either have more expertise about a particular topic, or for normative reasons, we care about their opinion because they're going to be affected by that issue. But their labels might be overridden in this general context. And so an approach here that can be used to address this issue looks at what's called multi-annotator architectures. So these are models that are trained with individual people's labels rather than aggregate. So if I have Alice, Bob, and Charlotte annotating an example of hate speech, I don't just want to know what do people think about it, I want to know what Alice thinks, Bob thinks, and Charlotte thinks. And then we can use that information downstream. This is really useful because it lets us measure uncertainty. So if we know the variance among our population, we can then look at later on if the model is predicting such a label, we understand that that label might actually be very uncertain. We can also look into flagging potential false positives and negatives. So in the example I gave before, if most of the women looking at something disagree with the majority on an example that targets women, we might think that example's been mislabeled. And finally, where we see examples where there's very high disagreement, it can help us in this sort of mechanism design process of understanding when, rather than using an algorithmic decision, we might want to route something to a human content moderator or flag this as a very complicated case. And so for this application, laptop likes me again. So for this application, there's sort of 3 challenges to look at. One is identifying examples where the target group disagrees, since they're likely to be affected. Modeling these ratings independently from human supervision. And finally, looking at ways to maximize privacy. We can model annotators based off their demographics, but that also involves learning people's demographics. And so this is going to basically be a 2-module process that's going to be combined to get this information. We have some text and we have some information about annotators, their demographics, and some survey responses about online preferences. In the first module, we're going to try to predict individual annotators' ratings. So we have Alice, Bob, and Charlotte annotating an example. Let's get Alice's rating, for example. This is going to take in the information as text and go through a large language model in order to predict that rating. In the second component, we're going to look into seeing who is targeted by that text. So in the example I showed before, that would be women. And then finally, we can combine this information. So now that we know that women are being targeted, and we have all our individual annotators' ratings, we can look at the predicted ratings of all the women in our data set on that example. And so by combining this information, we can get a sense of what the target group thinks about some hate speech. And so by looking at the improvements on the error rate, both at modeling individual annotators, the aggregate among them, which is the typical hate speech setting, and their variance, we see that including this information results in quite a bit of improvement on predicting individual people's ratings, as well as predicting the aggregate and the variance among them, when we include demographic information about annotators and information about online preferences. In addition, when we're looking just at the target group, we see that there's improvement at looking at the ratings of specifically members of targeted demographics. One interesting thing here is that if we look at individual features, not all features are equally useful for predicting what people think about an example. So by doing some forward feature selection, we found that training a model just on people's race, their opinion on whether toxic comments were a problem, and what social media they use, was equally useful to including a whole list of demographic information, so way more features. What this suggests is that many features that we might think are important for some tasks are not important for all tasks. So for example, gender turned out to not be a very good predictor at all. And so what this suggests is that these surveys on things like online preferences, things that are relevant to the task, but maybe not as invasive of people's privacy, can help to do this sort of modeling task. I'd like to conclude by talking about some of the broader trends in this issue and what we can do moving forward to deal with questions that come up when individual annotators disagree. And I kind of like to think of this as a bottleneck. We start out with something we want to capture, people's opinions about their world, their utilities maybe, like what do they need? And they care about different things affect them. And then we go to get some pool of annotators on something like Mechanical Turk. Already we have an issue because we have a distribution shift. Mechanical Turk is not representative of the entire world's population. It's mostly like white and young and from high-income countries. So already we have a distribution shift. We're losing demographic representation. Then we're going to sample a particular subset of annotators for each example. And here we have an increase in sample error because one of the issues that we see is not only that we're sampling a very small subset, but also that if we have a demographic that's important but not even minoritized, like women, 50% of the population more or less, but if you have an example targeting women and you just so happen to get less than 50% women, you might lose that information. In addition, we see that when we aggregate this text, we lose the opinions of minority groups. And finally, when we train these models, we've lost all calibration to population uncertainty. So at every step of this process, we're losing information. Essentially, individual annotators' utilities are certainly not the same as aggregated express preferences, and so we are losing a lot of information throughout this process. However, by taking this into account, we can start to address this issue. So first, we can do things like identifying the demographics that are relevant for a particular problem and making sure that we get annotators from that population. So we've seen examples where, for example, moderators on Indian political news sites might be hired from like Canada. Well, that seems like maybe a bad choice if we're trying to get people who have relevant expertise on the topic. In addition, we can allocate annotators to particular examples based on what we know is relevant to that example. So if we know that an example is targeting women, we might want to make sure that some women are actually looking at that. In addition, we can use these multi-annotator architectures to preserve information that gets lost in aggregation. And finally, by taking into account the variance between annotators, we can actually calibrate to population uncertainty, which is sort of a subject of ongoing research. And so ultimately, by taking into account how individual agents' utilities are not the same as expressed aggregated preferences, we can model individual annotators in order to uncover harms that can get hidden under traditional assumptions. Thanks very much.
Awesome. Let's take questions in the back, maybe.
Yeah.
So thank you for your talk. It's very interesting. I'm curious, you staked your talk here on the premise that classifying text through a moral lens by annotators is a moral good. And I'd say that's a risky assumption in that if you're classifying text through a moral lens, because there's a conflation between opinions and, say, harms, there's an argument to be made that classifying text as harmful or filtering text through a large language model is in itself morally wrong. So how do we justify, say, classifying text in this way? If it, in itself, by preventing harms, it's actually a net loss to society.
So I think if I'm interpreting your question correctly, you're sort of asking, like, does this raise the issue that classifying text is in and of itself like harmful? Is that?
Yes.
Yeah. So I've definitely seen that position before, and I see the merit in it. I would say a lot of the things I'm looking at still matter regardless of the intervention. So even if we think that like classifying text as in we are going to take this post down because it's offensive is something that's inherently harmful, this is still relevant if we're trying to do things that are not that kind of intervention, such as should we provide a warning to someone before they post this? So I think even under scenarios where we think there might be like issues with classification, this is still relevant if we're trying to do intermediate interventions. Yeah. Yeah.
So I also really enjoyed your talk. You touched on very briefly the relevance of what you're doing to RLHF.
Yes.
And I wonder what you've thought about, whether you've thought about possibilities of tailoring large language models for particular contexts and particular users, particular tasks, based on who's saying which response is preferable.
That's a good question. So I think there might be like multiple ways to go there. Some is like, like a bespoke language model for different people. That's not really something I've looked at, but I have looked at, can we try to like contextualize language model responses so they're taking into account things like, this is a speaker of a particular dialect, so don't like use the interpretation that you would use for a different dialect. That's work that's ongoing, stuff I'm looking at. Would be happy to talk later. Yeah.
Okay.
Yeah.
Could I ask?
Oh.
Yeah, that's second.
Yeah,
Yeah.
sure.
Yeah.
Could I ask a question?
Sure.
So isn't isn't giving power to the annotator group could also lead to adverse effects in the sense that you use women and of course that's but what about think of if the target groups are politicians or politicians of a certain party, or say the target groups are sex offenders, right? If you give them that much power that you take their opinion into account, they could use that to sort of drive the output of a model to not be truthful, but to be much more favorable to them, even though society may not see this as a desirable outcome.
Yeah, I think that's an excellent point, and it's something I've actually already been thinking about. So this work, I sort of scoped it to target group harms, mostly because this hadn't really been explored. I agree that that is maybe a major concern, not just for this research, but more broadly for hate speech research. Yeah, so if you have something where like this is targeting, I don't know, say Democratic politicians or something, then suddenly there are like multiple groups who are affected. Yeah, I think that's absolutely true. I think that's something that needs to be looked into. But I do think it's also not something that's like out of the realm of potential extensions of this, in the sense that this is currently looking at one target group, but I can definitely imagine extending this to look at like what are multiple potential affected groups who might disagree, and then we'd sort of have to look at more difficult concerns, like if this is maybe affecting politicians, but it turns out that other stakeholders are also important. So yeah, anyways, I think that is very important. Yeah.
Go ahead. Yeah.
Sorry. I was wondering, have you thought about like how to approach this problem if you don't have like full demographic information? What maybe?
Yeah, great question. Yeah, so I actually already have, that's a current project I'm working on, so we should talk after as well. But one of the things I think is interesting is trying to like cluster annotators' opinions and then see if there are sort of like, without knowing what that opinion, what group that opinion corresponds to, understanding that there might be like clusters of people who disagree. And so that's one way to sort of deal with issues where you don't necessarily know the attribute that's relevant to a particular thing. It also helps with issues with like intersectional groups as well. Yeah.
Yeah, well, I think
Yeah.
my question was a bit related to this one. So my question was, if your features, the reason why annotators disagree is not related to demographics. Like for instance, if annotators disagree whether a summary is good or not of an article, do you have ways to sort of mitigate disagreement in that sense?
Yeah, so that's like a more interesting setting, I feel like, because that's something where we might imagine is like maybe people have different values that they care about in like a summary. They want it to be like short, or they want it to be like highlighting particular points. I think that's a very interesting problem, but like it's also trickier because then we need to get at those individual features. Yeah, it's something I am thinking about.
We're running behind. Maybe one last question.
So, Chris, quickly building on that last point,
Yeah.
I wonder if this gives you a risk of false positives, where if you just have some annotations that are going to be noisy for a good reason, some probability of the time minority groups are going to happen to exhibit that noise more just for statistical reasons. And in those cases, just some, whether a summary is good or something might be targeted as hate speech.
Yeah, so I think like an ongoing question in this field is like getting better at distinguishing disagreement from noise. So we might expect, say, that the noise is more random in ways that we can measure compared to like a distinctly held opinion by certain people.
I guess I'm
Yeah.
just saying, if you take many samples from a distribution, sometimes it'll concentrate in a minority, which after all represents a small number of samples. And in that case, your way of detecting that it's not just noise, which is that it aligns with the demographic, might sort of pollute the model and make it think that something is harmful when it's really just kind of sampling.
Yeah, good point. Thank you.
I guess if you have any other questions, you can take it offline, and I'm sure we're going to answer.
Thanks, Anna.
Okay, really great, thank you.